Today's video is about writing equations. Students have learned about writing expressions earlier in Chapter 3, and in Chapter 7 we're going to be focused on writing and solving equations, but this video is limited just to writing equations. First, you should know that an equation is a mathematical sentence that uses an equal sign to show that two expressions are equal. So you can see in red here it shows expressions, and the first expression, a numerical expression, can be solved because we have all the information we need, whereas that second expression is an algebraic expression, and without knowing the value of x, we're kind of stuck. With an equation, you can see we've got terms on one side of the equal sign that would need to be solved, and then its solution on the other side. And in the case of this algebraic equation, we need to find out what the value of x is that would make that equation true. Again, our goal today is simply to write the equations. We're not solving them just yet. To write word sentences as an equation, you want to look for keywords such as the same as, is, or equals to determine where to place the equal sign. So in the phrase or in the sentence, the sum of a number n and 7 is 15. Is clearly indicates that that's the equal sign. And so you'll take the phrase sum of a number n and 7 and translate it to m plus 7. And then your 15 goes there. The equals would separate the two. In the word sentence, 12 times the number p equals 48. Equals clearly is your equal sign. So that's the goal we're going to have. We're going to talk a little bit about some key vocabulary related to addition, subtraction, multiplication, and division. We spent a lot of time on this in the beginning chapters of this unit, or in Chapter 3, identifying key phrases. We specifically highlighted the following phrases: added to, more than, subtracted from, less than, and fewer than when we were in that unit, because all 5 of those phrases indicate that those phrases need to switch the order. So for example, 9 more than x would actually be written as x plus 9. So many of you have a lot of experience with that, but certainly you can go back to lesson 3.1 and 3.2 to review that. Additionally, we've spoken about the word quotient, product, difference, sum, and I suppose you could add total. Those words also stand out because they indicate that it's the answer to a division, multiplication, subtraction, or addition question. So we should be familiar with all that vocabulary, but particularly the ones that are starred and underlined, because they are ones that are often confused. We're going to do probably 6 examples. We'll start with these 3. So our goal is to write the word sentence as an equation. Now I'm going to follow my own advice, which is when I'm looking for that equal sign, I'm looking for keywords such as the same as, is, or equals. So when I see the word equals right there, that's going to give me my equal sign. I see the word is, that's going to give me my equal sign. I see is the same as, that's going to give me my equal sign. So now I can go ahead and solve my expressions. The 12 clearly is going to go here, my 50 is going here, and my 18 is going here. And I normally wouldn't solve my expressions in such a formulaic process, but I want you to notice those patterns in the structure that we're following here so you can do the same. So all I'm left with now is my expression over here, 7 more than a number x. Well, I know 7 more than is an addition phrase, and more than does switch the order. So I'm going to write x plus 7 equals 12. That's going to be my expression. When I look at the product of a number y and 10, I know product means to multiply, so I'm multiplying y and 10. Now I could write y times 10, but I'm going to be more efficient and I'm going to write 10y. That's the most efficient way to write that expression, which then becomes the equation 10y equals 50. And then finally, a number m increased by 7. We know increase by means to add. That's not one that would switch the order, so it's simply going to be m plus 7. A few things worth noting. I'm not solving these. My goal, again, was simply to write the word sentence as an equation. We'll learn how to solve equations in a future lesson. Additionally, you'll notice that my variables are written in lowercase while my numbers are larger. It's important for that consistency so we don't mix those things up. Now, with these next 3 examples, I'm not going to follow that formula. I'm going to do one problem at a time. So I'm going to notice is means equals. I'm going to see the difference of x and 12 is my expression. So difference means subtract, so it's going to be x minus 12. and then obviously equals 20. I'm going to go back to this next example. It says half of z is 70, so I know is my equal sign. I know that half of z, of means to multiply, so I'm basically doing half times z. I can write it with a times sign, but again, even a fraction can be used as a coefficient, so I'm going to be as efficient as possible, making my z nice and sharp so it's not mistaken as a 2, and then finally write my 70. And then for the last example, 5 fewer than n is 20. I'm going to go ahead and underline is, that indicates my equal sign. And 5 fewer than n, fewer than was one of those phrases that switches the order, it means subtract, so it's going to be n minus 5, and then finally the 20. So that's good examples of writing word sentences as an equation. Sometimes we have problems that give us some scenarios that we could solve with an equation, and this is a good example. We know that perimeter is calculated by adding up the outside edges. So what they would like is an equation that could be used to find the value of x. Now, the bottom line is obviously it's x plus x plus x plus x plus x equals 85, but we can simplify that into a much easier way to understand and say that there's 5 x's. So the way I would write this answer is I would say 5x, that is 5 times x, would equal 85. And that's my equation. I'm not solving it yet, but that's the equation I would use if I wanted to solve this problem. Over here, because there are 6 x's, it's a very similar problem. 6x equals 90. And again, not solving it yet, but we are going to be prepared within the week to be able to solve a problem like this with no difficulty. The last question I'm going to use in this video is a word problem, and our goal will be not to solve the word problem, although I know you guys will know the answer. It's pretty straightforward, but it's an idea of practicing, taking a word problem and changing it into an equation. A lot of people like working with equations because it's very direct. There's no confusion. You can follow a standard set of rules to solve. So what we're going to do is we're going to try to translate our word problem into an equation so we can solve it. So the question reads, you spend $100 on 2 packages of socks and X shirts. Each package of socks costs $10 and shirts are $20. So we know the total amount of money you spent, and we know how you spent your money. What we don't know is how many shirts you bought. So we can take this apart in an equation, and again, we'll use that equal sign to separate the amount of money we know we paid and what we spent. Now, we know what we bought was 2 packages of socks and X number of shirts. So the 2 packages of socks, I know exactly what that part of the equation is going to be. It's going to be 2 times 10. I don't need to use a variable for socks because I know the cost of the socks. So I know that 2 packages times $10. But then I also am buying some t-shirts. I don't know how much I know how much the t-shirts cost, but I don't know how many I'm getting. So my variable is going to be the number of shirts I'm buying. I'm going to choose X to represent the number of shirts, and I'm going to multiply that times 20. Now, obviously, the cost of the socks and the cost of the t-shirts would be added up. Now, in this equation, I have done what I needed. I was asked to write an equation I could use to determine the number of shirts I bought. But to take it a step further, I know this answer, and I can simplify this. And so I want to make my problem as well done as it can be done. So I'm going to write 20 plus 20x equals 100. And that's going to be the best equation I can have. Now, once I can isolate some things and solve this, I can find the actual cost or how many t-shirts that I bought. And again, I made this problem simple, so it would be one you could figure out on your own. Once we've gone further into the unit, you'll be very well prepared to solve a problem like this. Thank you for sticking around to the end.